We'll take it one step at a time. So let's look at a smart contract. So I'm going to give you this, and I'm going to tell you that you will have to deal with this, right? And then we'll back off. We'll do basics again, okay? And then once we finish the basics, we'll go back into code. Sound good? All right, so let's look at an example. Yeah, so a bet. What's a bet? How does a bet work legally? What are legal obligations that come from a bet? Is a bet legally enforceable? It's a contract, right? I think it will be X, you think it will be Y. If I win, I get your money. It's a contract. Yeah? Basic contracting. So in a typical contract, how would we write this up? Well, we would write this in some sort of legal framework, right? So this is let's consider this the natural language template that gives us the background to transfer this into code. And guys, you will have, a lot of you, most of you, I think in your careers will have to do either this yourselves or understand if somebody else did it correctly. Yeah? Okay, so this is what all of us are comfortable with. These are the terms, the natural language terms that we would say, yeah, we understand this. Now let's put it in a legal framework. You turn this into a 10-pager, you know, provisions on what jurisdiction applies, is this contract a contract that is subject to changes, amendments, are they going into the contracts, severability, I mean all these miscellaneous contractual terms you may put in here, yeah? Amendment, notices, all these things that could go in. Yeah? So typically in a typical legal contract, you know, the first page or so in a smaller contracts defines what's going on, which terms are being used in what way, and then you have some substantive provisions that explain how the legal relationship between the two parties are governed, and then in the end, we're doing all the legalese. Yeah? So you would basically take this and put this into such a contract. So Bob and Lisa, they want to have a bet. They both say, okay, we don't want to give you a full Ether. This is a small bet. We're giving you 100 Wei. Yeah? So Bob says it will rain in Chicago tomorrow, today. Lisa says it will not rain. And they're both willing to put money behind their beliefs.
Yeah. The parties have to determine who the oracle is. We call that an oracle. It's a non-certified, non-blockchain data originating data source that makes a determination for the outcome of this bet in a smart contract. In this case, Bob and Lisa have to appoint Teresa or whoever to make the determination as to whether it rains in Chicago today or not. Yeah? We call that an oracle. So how do you pick the oracle? And how does the oracle in the smart contract make those determinations? The parties themselves can't do it, right? That would lead to an open conflict. So they select an oracle to make that determination. The oracle then decides, in these contractual terms, and I'll show you the code in a second, what the outcome of the bet is. Once the oracle has made that determination, what happens with the Wei? It is held in escrow, sorry, not escrow. It is held, we call it as a deposit. And in a smart contract, we call that a deposit. It's like an escrow. So if you think of it as a lawyer, it's the same concept. What's an escrow? Mr. Evans, what's an escrow? Why? It's a neutral, right? It's a trusted third party who holds the money for the benefit of allocating to the parties who win in this case. Yeah? Okay, so we have to figure out, one, who this trusted third party is, and two, how the code releases the deposit if and when the oracle makes a determination as to whether it rained or not today in Chicago. It's just how coders don't use that word. This is law. We're talking, okay, guys, you learn legal terminology, and that's valuable, but you have to retranslate that terminology to code. So for coders, if you go, a lot of them know enough about the law to know what escrow means, but typically you want to be able to use their language. In this case, we would call it deposit. You deposit it into the contract. Okay, so let's look at the code. Guys, I need you to write this kind of code for our final exercise. Yeah? You might say, whoa, what's this? Yeah? Okay, so let's start going through it by line. So first of all, we're setting up this as a contract. And now, by the way, I'll give you a line-by-line item with all the downloads that you have to do, every step-by-step analysis later on in this lecture. So, and we have another whole month to deal with this. Yeah, so we'll get you ready. So, first of all, this is the contract. Yeah, so open bracket, address of the puts in the address of the person who claims it will not rain for purposes of this bet. So that's here Lisa, yeah, versus Bob's address, which means it will rain. So it's very simple. Yeah? So Bob has XYZ address with the wallet attached. That address is now associated with it will one stake versus the other address. Yeah? It's very, very basic. And then you need to also have the address for the oracle. That you have to define who this person is who makes the determination as to whether it rained to Chicago or not. Yeah? You have to identify this otherwise anonymous person by way of the address. That has to become a parameter in the contract. Yeah? And then, of course, start time. When do you start counting as to whether it rained in Chicago today? Yeah? Okay. And then you have to define what rain status is. Initially, the rain status is -1 because you haven't done the contract as of yet. Yeah? If it becomes 1 or 0 in this case, that would mean it rained or it didn't rain. Yeah? Okay. So we have an oracle, we have a start time, and now we're defining a function. And I'll give you a cheat sheet on these functions later on, yeah? So you can see the sequence. So function here is called bet it will rain. If we have bet it will rain, that requires that the message value coming from this address that says it will rain has at least more than 100 way, equal or more than 100 way in that wallet address available. That's the deposit. Yeah? So that's this one here. Equal or higher or equal to 100 way. And will rain for purposes of this function is the message sender with over 100 way. And then we'll see the if function later. Yeah? So you have to predefine this. Okay. Next one is the same thing, only in reverse. Bet will be it will not rain. And if that outcome is asserted or true in this contract, as validated by the oracle, you are paying more than or equal in this case to 100 way from this address. It will not rain. Yeah? So one is I'm paying from this address this money for this function. The other one is I'm paying from this address this money if this is true. Yeah? Okay. So, of course, there is no payment unless you define what rain status is. Yeah? And that is the oracle. So the message sender here is the oracle, as defined up there. Yeah? So the function here is set rain status, meaning determine what the status is, define it,
In the message sender, here we only have message values. Here the message sender would be the oracle as defined by that address up there. Yeah? So whatever that address determines as the message sender defines what the rain status is in Chicago today. Okay. Now, how do we resolve the bet? It's a basic if function, guys. So everybody who has programmed Excel before, almost everybody, okay, half the class, you know how this works, yeah? If XYZ, very basic, what's a very basic if function in Excel, Mr. Evans? If the value in column A is over 100, return 1. Yeah? So all the spreadsheet does it counts all the values in column 1 that are over $100. Yeah? And then spits out a 1, counts them. If then, there's also a count if function. Yeah? There are different ways to program this. The same thing here, guys. This is not rocket science. It's just a question of how you put it all together. Yeah? Okay, so the function here is resolve the bet. What do we need to resolve the bet? Well, we need to determine the rain status and the payouts from these senders. Yeah? That's all it is. So, require here start time. How do we define start time?
We set it as now, so whenever the contract is deployed.
Okay, but so what is the equal, larger or equal 60 times 60 times 12? You got it. Exactly. Yeah? The course of the day. Yeah? Exactly. So if it will not rain has the address, then we transfer this balance, yeah, in this case. So if it will rain wins, then transfer the respective balance that is associated with it will rain. Yeah, that's this. Up here, yeah? It's this. It's this and that. That's the message sender equals, so it will rain with this value is the message sender. That's what you take and transfer. Yeah? Then will rain message sender will be transferred, and then this balance means the entire balance that was staked. Yeah? And then same goes with, so if it is will not rain, then the will rain will have to be transferred, and the reverse is if it will rain wins, then the will not rain amount will be transferred. Yeah? Then we have to ascertain rain status. So is rain status -1, or is rain status, if rain status is 0, which is not the basic state of the rain status, which is the beginning state, then we will not rain will be transferred for purposes of that balance. Same for if that's not the case, the will rain will be transferred in that balance. So it's a very basic if-then function. Now, all it takes really is that you're putting in the right addresses, the right stakes, and that you determine the outcome of the rain status in that sequence. Once you have that, it will compile. Yeah? Okay, I see there's some people getting uncomfortable with this. Guys, this is literally, it's a question of messing with it until it works. So it takes a little bit of a tenacity, a little bit of the willingness to put yourself out there and make it work. Once you understand the syntax, once you understand the command lines and how they fit together, you can put this together. Yeah? And by the way, you can do this kind of thing for anything, really, that you want to code. This is just a very basic example of what this does. Yeah? Questions? Okay. Okay. Yeah.
What happens when you run into the problem of the renegotiation? Because in real, like traditional contracts, it's oftentimes both parties go to negotiate. But
can we renegotiate this contract?
not necessarily, but
How does this work? Very good question.
So the DOS is saying you can do the same thing over again, define the start time, the end time, and require an oracle input as defined previously in these parameters. Should you do that? Is it a good idea to put real-world negotiations into this contract? Which is, by the way, that's where you're seeing your value, right? You're saying, oh, this is what lawyers do. They help optimize this and get better outcomes for their clients. Ms. Jones, what's the problem with what you're suggesting? You're correct. This is what happens today. Why is that what happens today arguably suboptimal that can be optimized with this contract? Why is this arguably better? Correct. And if there is no negotiation, what do you increase? Time efficiency, outcomes, certainty. Remember, it's all, why do people hire lawyers? Because of uncertainty, right? Lawyers are getting hired to give them more certainty about outcomes they desire. Supposed certainty. Yeah? If you code it, what you get for sure. You know that this contract executes based on these parameters that you defined, that the parties agreed to define. Yeah? That is certainty. Now, what's the one item where, even in this contract, you have uncertainty? Okay, so there's this thing. Did we actually translate this appropriately into code? Yeah, is the natural language legal meaning of what we intended to do encapsulated in this code? That's one problem. Guys, that's your job as lawyers. Is this what the parties wanted? Is this encapsulated in this code? Yeah, that's one item. What else? Ah! Tell me more about those. Guys, this is a thing of beauty, I would argue, okay? Because it takes all the legal messes that we're otherwise getting ourselves into and puts it into specific parameters that the parties are curtailed by and that auto-execute. The one dirty thing here is the oracle. Sorry, I shouldn't call it dirty. I should say it is an element of uncertainty. Why in this contract? Absolutely. The oracle may mess it up. The oracle may not be a good oracle. That's it. Now you might say, it doesn't matter what it is. You picked that oracle, you left it up to the oracle to make that determination. Right? Okay. So, okay, so this is all coded. The transfers, everything is automated. The deposits are in, nobody can get out of it. correct. You're absolutely right. And this is a distortion, because how do you know that you picked the right oracle to make that determination? Now this is a small bet. Now imagine this is a higher stake bet, you know, where people really have an involvement. So the quality of the oracle becomes increasingly important, right? Because we have nobody else to make that determination for us. So how do you get good oracles? And oracles that are vetted by the parties. You might say, well, based on our information that both parties had, we picked this oracle. Oracle is X as defined in the contract. But those two parties are subject to information asymmetries, and then they only based it on their own personal cognition at that point in time. Right? Had they had more foresight, more of an understanding, they could have picked an oracle that would have appropriately made determination as to whether it rains today in Chicago or not. Now I'm oversimplifying this, yeah. So because we want to start very basic, that you can get into extremely complex structures with this. Yeah, this is just basics. So the oracle is the item in this contract that makes external input possibly necessary. That takes away uncertainty that otherwise is guaranteed by this contract. And I want to be very clear, guys. This contract makes it absolutely, I would argue, impossible for the parties to not get the outcome of the bet as allocated. There is no legal dispute here. There is no, the only one is the oracle. Yeah? But even there, as you said correctly, the parties picked it. Once the parties make that determination, they're subject under this contract to the outcome of their determination.
So that would require a major culture shift in our way of doing business. Because that's that front-loaded hyper-negotiation and then just accepting the consequences. People don't feel that way most of the time right now. So there definitely is some mindset shift.
Does everybody agree with this?
Yes and no.
Why?
Because if you're doing 500,000 transactions a second, you want the bulk to be okay, even if one will be low.
You see that? And give me another argument why this is really the same with a higher level of certainty than what we're doing today. Is this really, what's the culture shock that comes out of this? Why is this a culture shock? The legalities of this are the same. There's nothing different here. But what's the shock?
One of them is instant settlement.
It's okay, so we have instant settlement, what else?
Centralized versus decentralized too. It's like if you make a bet in Vegas and you go complain to people that bet at Vegas, but here, if it's not the outcome you want, or the oracle doesn't do what you want, there's nobody to go complain to.
That is absolutely correct what you're saying. But why do we want a legal recourse? And that's part of the culture shock. So it's a combination of the syntax is missing. You're putting this into coding terms that are no longer natural language, that are command lines. So you're losing the natural language connector that humans tend to require, right?
Yes. And people are afraid that the other party's not going to hold up their end of the bargain. And I think what, like Dan's saying, it's maybe hard to shift your thinking that to accept the fact that under a smart contract, the other party doesn't have a choice whether or not to hold up their end of the bargain.
It's auto-executed. There is no, oh, it didn't quite work out and I disagree with this. It's, once the oracle makes the determination and you selected the oracle, it auto-executes. Now what do we get with this auto-execution? Certainty and speed, which is what capitalism thrives on. So guys, I would argue that these contracts, let me use this word, put capitalism on steroids.
Why? We get speed, auto execution, and certainty. All the messes that we're otherwise dealing with as lawyers, all the uncertainties, all the human conditions that we're otherwise dealing with in these contractual arrangements, they all fall out. Instantaneous settlement, speed, and certainty. Yeah? Now, the one item where you might argue creates a problem for the optimization potential that comes out of this contract is the oracle. Again, for now we can say, well, the parties picked the oracle, end of story. They're subject to the decisions of this oracle. Two things are going to happen as these contracts get more complex. People will want a verification source for the selection mechanisms of oracles. The more complex they get, the more certainty they want to have in the outcomes as determined by oracles. Yeah? That's a necessity here. Yeah? And the second thing is what? People are going to want to have recourse if the code has bugs and we haven't done that yet because we're using very simple code. Now, there's some people that argue that even these very basic lines of code will create outcomes that have not been anticipated by the parties. I'm talking about these very basic lines of code can already have bugs that we all don't quite understand right now in the interplay of these command lines. These very basic lines may already trigger outcomes that we didn't anticipate. Typically, we see this going through. These bets are automated. They're going through, right? So you might say this is a good template of code, of a protocol for these kinds of bets. Now, what happens if you change the parameters slightly in a different setting and the code that you know works super well as a template for these kinds of bet in a different scenario or all of a sudden has an outcome that you never anticipated? What do we do now? That's what we have to fix. So you need to have a recourse for outcomes of template codes that you didn't anticipate. Nobody can do that right now. Just to be clear, guys, everybody, okay, I'm biased. I would argue that most people who understand what this means for society will want the optimization potential, the certainty, the speed, and the outcomes that are generated by this code. What they don't want is the uncertainties that come out of bugs that nobody can foresee because we have limited cognition and foresight, and we couldn't backtest all the outcomes because we didn't understand future scenarios in which this code would generate outcomes that we didn't anticipate or intend. Yeah? So what do you do? And this will, as this grows, this will happen more and more. It will work in 80 to 90% of the cases, but there will be cases where it doesn't work because the parameters that were fed into this contract, that are part of the contract, react differently. The code reacts differently in different settings. Yeah? So what do we do if this template does not work as anticipated? Bad luck. Money's gone. Parties have a problem. Guys, that's when we need to find legal recourse mechanisms for this code, intra-blockchain. Why? And I'm sorry if I'm stretching you too far right now, but because we're just basically learning this code. Yeah? But imagine that these lines of code have outcomes and bugs that we can't see right now. It looks clean. It looks like it does all the things we want it to do. Yet there may be problems that we don't understand. What do we do with those problems down the line? What's happening with this right now? Well, would it? Right now, that's the only way, but is that the way we would handle it? So, this is the real question here, guys. Everybody with me? So, let's say this is a $100 million contract, $100 million bet. Something goes wrong. We
change the parameter slightly, and the code has a bug that we didn't understand existed in the code. And the outcomes of the bet are not ascertained as intended by the code. What do we do today to fix that outcome, that unintended outcome of this bet? That's exactly right. The overwhelming majority of people who are subject to these bad outcomes, they're just taking the hit. And say, okay, well, I'm not going to sue in court. Why not? Why don't they take this code and say, hey, I lost $100 million. The code did something wrong, and I never intended it, and I lost my money. How can you claim that the people who wrote the code should have known that there was a bug in the code that could have triggered a $100 million loss down the line for somebody who did not know that this loss that this bug could have been in the code? Yeah? So there are all these ifs that how can you ever show cost? In America, we use it typically about 4 costs, right? Among other measures. How do you show that? Not only do you don't have jurisdiction. 2, you don't have a judge that understands this. 3, you don't have an expert who explains why this went wrong, this code. And 4, you cannot find cost. How do you allocate cost for this? Even assuming that you use jurisdiction. Yeah?